This video is over the practice questions in topic 25. As always, you should be reading through the text portion of this. The video is only over the practice questions. So this is looking at linear relationships. And starting with practice number 1, Layla is filling a tank with water at a rate of 5 gallons per minute. The tank already has 190 gallons of water in it. The tank holds a total of 300 gallons of water. So, what calculations with the 5, 190, and 300 will find how much longer it will take to fill the tank. There's different ways you might think about this, but you might think something like it has 300 total and it already has 190. So you might do 300 minus 190 to get that's how much left to fill. And then you might know that if we need to fill 110 gallons at a rate of 5 gallons per minute, that the correct calculation there is 110 divided by 5, getting 22 minutes. Now let's look at setting this up with a linear relationship. So if you weren't sure what calculations to do, using a linear equation can help. Or on the other hand, if you know what calculations to do, that can help you come up with a correct linear equation. So it can go either way. So the change quantity, if we look at this, that's the one that has the per units, gallons per minute. So the change quantity is that 5 gallons per minute. The per unit in the change quantity is the input quantity. We don't have a number of minutes given in the question, but this would be the number of minutes. And also a number of minutes that Layla has spent filling the tank. So now we can put some pieces together. We have the unit change value. We just said what that is. That's the 5, so just the number part of it. That's going to get multiplied by the x value, the input quantity, which we do not have. That's what we're potentially trying to find. So I'll just put x there. Plus or minus. So we need to look at, was that initial value positive or negative relative to what's happening? So we have some water already in the tank and we are filling it fuller. So the change value is positive being added on, and the initial value is positive as well. So you might think of this as the 190 starting point plus the 5 gallons per minute times the number of minutes x, rather than the 5x plus 190, 190 plus 5x. But Alex will have you filling in blanks in a particular order. So, and then the end value is the 300 that it's moving towards that maximum. So now we have an equation to solve. 5x plus 190 equals 300. And the steps to solve that is first subtract 190. So you get 5x equals 110. Then divide both sides by 5 to get x equals 22. So exactly the equations that you may have come up with it without even writing an equation. Next example, the next few examples, we're looking at money. And you have to be careful with money, thinking about whether things are being added, subtracted, positive or negative. Kind of depends on the context of what you're working with. So number 2, Salma went home with $81 from selling t-shirts at a festival. She had to pay $45 for her booth. She sold the t-shirts for $7 each. So the input variable We look for this. We don't have the word per, but we have each here. She sold the t-shirts for $7 each. That would be $7 per t-shirt, making t-shirts the input value. So X is going to represent the number of t-shirts sold. So if we just want to talk about Salma's income from selling the shirts, so income is just the amount coming in. That would be the $7 per shirt times the number of shirts, which is X. So the price per shirt multiplied by the number of shirts, or I can just write that as 7X. Then the expenses, that was the $45 booth fee. So the text up above here explains the profit or loss formula, that profit or loss is income minus expenses. So profit or loss, income minus expenses. The income we said in part B was 7X, and the expenses was the 45. So we have 7X, it's minus 45 because that was expenses. And then we end up with the $81 is her profit. That's what she went home with after both selling the t-shirts and paying the expense. So when we're solving this, 7X minus 45 equals 81. The first step is to add 45 to both sides and get 7X now equals 126. The 7X is what we said was our total, Salma's income. And so that means the 126 also is the income. So she actually made $126. Once you say she took home 81, but she had paid the 45. And so if we reverse that and say before she paid the 45, she had made $126. And so then we take and divide both sides by 7. So we're dividing the total that she made by the $7 per shirt to get the number of shirts sold. We get that would be 18 t-shirts sold. Number 3, Tammy received a $70 gift card for a coffee store. She used it to buy coffee that cost $7.61 per pound, and after buying the coffee, she had $39.56 left on her card. So how much did she spend from the card? Started at 70, ended at 39.56. So what was subtracted? Well, if you want to find what was subtracted to get this result, you can just switch and say 70 minus 39.56, and that is 30.44. So that's the amount that she spent of the card. And so if she spent 30.44 at a rate of 7.61 per pound, then what we want to do with $2 amounts, we don't want to multiply dollar amounts together, we want to divide them. So we're going to take that 30.44, and that was divided amongst at a rate of divided at 7.61 for each pound. So how many 7.61s is that? And that would come out to 8 pounds. Now, writing this as a linear equation, because that's something you'll be asked to do in ALEKS, we would have the change amount, always it's what goes next to X. And so that's the 761 per pound. And this change amount, this is money being spent. So I'm going to make that be a negative 761 for the change amount. And then we'll have a positive initial value of 70. So again, it might be more intuitive to you to write the $70 original amount on the gift card, then minus spending that 761 per pound times the number of pounds. 761 per pound getting multiplied by the X pounds will give the total spent. But again, it'll be fill in the blank in a particular order. And then the ending value is the 39.56 that she had left afterwards. So if I have negative 761x plus 70 equals 39.56, first step is to subtract 70 from each side. So it's negative 761x equals negative 3044. And that negative is just an indication where we used words here. How much did she spend? Now that's being represented algebraically with the negative sign, as is the 761, also with the negative sign. So those negative signs will cancel each other out with the division, giving that positive 8 pounds. All right, then last example, number 4 here. Albert bought some books, spending a total of $71 after a discount of $5 off his total purchase. Each book cost $4. So for the linear relationship equation, the each book costs $4. That's the change amount. So that's going to go being multiplied by the X. And we'll think about whether that should be positive or negative. The 4X represents the total price of all the books. So he brings his however many books to the checkout. They ring it up 4 times X. Then they take off, they subtract that $5 discount. Or you can think of it as like that initial value that like he already started out at like 5, sort of -5 that he had to pay, but then that got the price of the books added onto that, to end up with the 71 total that he needs to pay. So 4x minus 5 equals 71. As we solve that, adding 5 to both sides reverses the discount, giving back the total price of the books. And then we divide that by the $4 per book, getting the 18 books that he bought. 76 divided by 4.